9.121 states, a gas expands isentropically through a converging nozzle from a large tank at 8 bar and 500 Kelvin. Assuming ideal gas behavior, determine the critical pressure P star in bar and the corresponding temperature in Kelvin if the gas is air. The problem states that we have a tank with a converging nozzle. So I'm going to go ahead and draw that. And it gives us the values of T naught, which is inside the tank, and P naught, which is T naught was equal to 500 Kelvin, and P naught was equal to 8 bar. In the problem, it asks us to find P star and T star. This happens when M is equal to 1, which occurs at the throat. In the chapter, equation 9-50 says that T naught over T is equal to 1 plus K minus 1 divided by 2 times M squared. And then equation 9-51 states that P naught over P is equal to 1 plus K minus 1 over 2 times M squared. And all of that is going to be raised to the power of K divided by K minus 1. When M is equal to 1, both of these equations can be reduced. So 950 can be reduced to T naught over T star is equal to K plus 1 divided by 2. And equation 951 can be reduced to P naught over P star is equal to K plus 1 divided by 2. And all of that is going to be raised to the power of K divided by K minus 1. So we're going to go to our ideal gas tables, and we are solving for air. So you're going to go to table A20, and you're going to look under air, and you're going to get the K value is going to be 1.4, and you're going to use temperature as 500. So now we're going to take our equation T naught over T star is equal to 1.4 plus 1 over 2. And you get that from this equation up here. All you're doing is you're plugging in your value of 1.4. And then you're going to plug in the T naught, which is given in the problem at 500 Kelvin. Now doing this, you can solve for T star by rearranging, and you get T star to be 418 Kelvin. So now we are going to now we just plug in our K value for our second equation in 9-51. We have P naught over P star is equal to K plus 1 over 2 to the power of K over K minus 1. You plug in 1.4 for K, and for P naught, which was given in the problem, you're going to plug in 8 bar, and you arrange to solve for P star, which gives you 4.24 bar.